Okay. Y equal to tan x minus pi over 2. If you look at the first question, the graph of tan, we say the period for tan is pi. But then also, if you look at the first question, or if you remember the basics when we were drawing, the asymptotes are between negative pi over 2, not including. So it's between negative pi over 2 to pi over 2. So in order to isolate x, you add pi over 2 to every side. So x is between 0, if you add negative pi over 2 and pi over 2, and pi. So once you go and graph it, the asymptotes of the graph you are drawing is at 0 and at pi. You need to still find the increments. Between 0 to pi is pi over 2. Between 0 to pi over 2 is pi over 4. Between pi over 2 to pi, half of it is 3 pi over 4. Again, you can do that by adding the endpoints and then divide it by 2. So the behavior of tan, it doesn't have negative, nothing is multiplied. So it's between... So now that you want to graph it, the behavior of tan is that the third increment is positive 1, 0, and then negative 1. So here is the shape. And again, that comes from the general model. You can always plug in a point like 3 pi over 4 into the equation. 3 pi over 4 minus pi over 2 is pi over 4. Tan of pi over 4 is 1, and that's confirming. When x is 3 pi over 4, the outcome is 1. When the x is pi over 2, y is 0. When x is pi over 4, y is negative 1. And again, that's over 1 period. If you were graphing it over 2 period, you could have continued from either way. And then you would have another pi. So that's half of that is 3 pi over 2. Half of 3 pi over 2 and pi. Exactly in the middle of that is 5 pi over 4. You do that by adding the 2 and divide it by 2, and then 7 pi over 4. So you basically continue with the same model. I'm going to use another color for this one. So you would have 1, 0, negative 1. That's the graph. For 1 period of cotan, we have asymptotes at 0 and pi. If you look at again the first question, so you have x minus pi over 2 between 0 to pi. Then you're gonna solve for x. Again, that's for 1 period. X is between pi over 2. And if you add, get a common denominator and add here is 3 pi over 2. So once you go and graph it, for 1 period again, if you go from pi over 2 to, let's say 2 pi over 2 and then 3 pi over 2 here. That would be the asymptote, because that's the 0 to pi is the asymptote. Now we shifted. And then now you're going to find half of these. Pi over 2, 3 pi over 2 is 4 pi over 2. Divided by 2 is just pi. And then half of that pi and pi over 2 is 3 pi over 2 divided by 2 is 3 pi over 4. Half of pi and 3 pi over 2 is 5 pi over 4. Again, you need to have the chunks here. If you are just graphing cotan, then the graph would have been, just by the behavior of cotan, here would have been the graph. Again, for one period. Now you are graphing negative cotan, so you are flipping it. So the graph would look like this. And then you are subtracting 2, so you are bringing every point on the function 2 down. So that would be 2 down. I'm going to use green here. So 2 down, it's going to be this point. 2 down from the 0 is right here. 2 down from 1 is -1. So once you're graphing this one, the asymptotes are the same, but here is the graph. Okay. Since graphing for 2 period, you're going to graph something identical here. So this is, every chunk is pi over 4. This is going to be 7 pi over 4, 8 pi over 4, which is 2 pi, 9 pi over 4, and 10 pi over 4 that it's here, so it's 5 pi over 2. That's going to be the next chunk, and you copy these points exactly here as well. So for this one, for 9 pi over 4, it's going to be -9, -1. For 2 pi, it's going to be -2. And then for 7 pi over 4, it's going to be -3. So again, these are periodic function. You're going to just copy them for every period. So just to remember and have in mind that this is the same thing as -1 over sine 2x. Exactly the way that we started to graph cosecant. We can always start with graphing sine. So knowing that the period is pi because you have 2x between 0 to 2 pi for sine, but then knowing that it's in denominator, so it's going to be bounded. But x, you divide everything by 2, is between 0 to pi. So once you go and graph it, again for one period, if you are graphing it for one period, here is what you do. 0 to pi, and then half of that is pi over 2, half of that is pi over 4, half of that is 3 pi over 4, and going between -1 to 1. So if you're graphing sine, you would start from 0, going up, down at pi over 2 to 0, and then going to least at the end of the -3rd increment, at the 3rd increment going to -1, and then back to 0 at the end. So that's one period. If you were continuing for another period, then you would have had to 2 pi, half of pi and 2 pi is 3 pi over 2, half of that is 5 pi over 4, and half of that is 7 pi over 4. We had done multiple of them, adding the two ends and dividing by 2. So if you were continuing this model, you would have get what you have. But then knowing that this is cosecant, that's why I didn't put equal to 0 here. I removed it. Because every 0 will make the denominator 0 and it's going to be asymptotes. So if I use green for the asymptotes, every 0, it's going to be 0, asymptote. Here's a 0, so it's going to be asymptote. This is going to be 0. It's going to be asymptote. Asymptote and then asymptote. So knowing that this is cosecant, so in reality you are flipping the function. So you would say every point will be reciprocal, so the smaller the value, the larger will be. So far, what I'm graphing in green is cosecant of 2x. But I need negative cosecant of 2x, so for my final graphing, it will be, and I'm going to use black, flip of what I have in green. So here is the final graph. That's in black, and that's the final graphing. If I was asked to label some of the points, so for example, this point right here, it would have been 7 pi over 4 comma 1. Or like this point right here, it would have been pi over 4 comma negative 1. Okay, number 12. Cosecant pi x. So you would put pi, again, think about this as of 3 over sine pi x. And then knowing that sine is between, you can say 2 pi over pi, so period is 2, or you would say between 0 to 2 pi for cosecant, so you divide everything by pi to isolate x, so x is between 0 to 2. So once you go and graph it for 1 period, you will be graphing for 2. If you are graphing for 2 period, then you're going to add 4 here. But for 1 period, half of 2 is 1. Half of that is 1/2. Half of that is 3/4. Sorry. Adding 3/2. Adding 1 and 2 is 3. 3 divided by 2 is 3/2. And then adding another period, it's going to be 4. Which we're going to get to that. But then multiplying by 3, you can graph 3 sine, that's fine. Or you can multiply 3 at the end. So I'm going to start with 1 for sine, and then maybe later expand it to 3. So then you start from 0, you go up to 1, going back to 0, going to negative 1, going back to 0. Half of 2 and 4 is 3. Half of 2 and 3 is 2.5. Half of 3 and 4 is 3.5, which is 7/2. Since we are getting close to 15 minutes, I just continued, graph the second period, then you flip the points because it's cosecant, it's reciprocal, and you multiply every point. If it's 1, it becomes 3. If it's negative 1, it becomes negative 3. So you multiply by 3 to get the final. So the green graph is the final graph. That's all.